Alright, in this video we're going to be calculating the enthalpy change or the heat change of the reaction using the standard heat of formations. So the enthalpy or the heat change has a symbol of delta H, standard of the reaction, and the standard heat of formation symbol is going to be delta HF, standard right there. And once you know the heat of the formations for the products and the reactants, the delta H of the reactions can be easily calculating by doing the sum of the delta H formation of all of your products minus the sum of the delta H formations of all of your reactants. And this is more like in a mathematical problem where they give you the delta H formation of all the products and the reactants, and you have to just plug it in this equation. However, you have to know what the delta H formation is going to be for anything that exists in nature, or another way of saying the naturally existing elements. And that's going to be 0. So for example, the delta H formation for O2 is going to be 0. The delta H formation for F2 is going to be 0. The delta H formation for sodium solid is going to be 0. And obviously the O2 is in a gas and F2 is in a gas as well. So you want to write down the gases there. And if you once you know those and you know the delta H formations for the reactants and products, you can easily calculate the delta H of the reaction. So let's go ahead and use that knowledge to answer this question. So we're told we have the CH4 and the Cl2 reacting together to make CCl4 and 4HCl. And we got to figure out what the delta H of the reaction is going to be here. So if I want to go ahead and write that out, the delta H of the reaction, and we said it's going to be the sum of the products minus the sum of the reactants. And your products here are going to be the delta H formation for CCl4. Okay, so that's one of your products. Plus, since you have 4 HCl, so this is something you got to be really careful. You got to take care of all your coefficients. So it's going to be 4 times the delta H formation for the HCl. Okay, so those are going to be your products minus, in your reactants you will have the delta H formation for the CH4, and then plus, I'll write that on the bottom here, delta 4 times the delta H formation for the Cl2. Okay, and seems like I know we're given the CH4 formation, the CCl4, and the HCl. We're not told anything about the Cl2, but then keep in mind the delta H formation for the Cl2 is actually going to be 0 because that's how Cl2 exists in nature. Okay, so now let's go ahead and plug those values in. So let's say I have the delta H of the reaction here. And that's going to be equal to the CCl4 is negative 96, okay, and then plus the delta H formation for HCl is minus 92, so 4 times minus 92. So those are your products minus on your reactants. You have CH4, and that's only going to be minus 75. Okay, so then from here is just a matter of putting them in the calculator. So this Cl2 is going to be 0, so keep that in mind. So let me just go ahead and plug that in the calculator and let's see what that comes out to be. Okay, so when you go ahead and do this math, this delta H of the reaction comes out to be negative 389 kilojoules per mole. Okay, so that's how you're going to be calculating the delta H of the reaction. Now, there are going to be times when in the given question you are actually given the delta H of the reaction and you have to find the delta H formation of something. For example, in this particular question where we have IF7 reacting with I2 making IF5 and the 2IF, we're given the delta H of the reaction. We're also given the IF7 delta H formation, and we're also given IF5. We're asked to figure out what the delta H formation is going to be for the IF. We're not told anything about the I2. What's the delta HF formation going to be for the I2? Well, that's iodine solid, and that's how it exists in nature, so it's going to be 0. Okay, so now let's go ahead and plug those values in, or let me just go and write that out first. Delta H of the reaction is going to be equal to uh, delta H formation for IF5 plus 2 times the delta H formation for IF. Those are your products, minus the delta H formation for the IF7, and then plus the delta H formation for the I2. Okay, so I2 is going to be 0, so I can just cross that out. And let's go ahead and plug in the rest of these values. So your delta H of the reaction is minus 89, so I'll just go ahead and write that out there. The delta H formation for IF5 is going to be minus 840, and then plus, you got 2 times the delta H formation for the IF, so we'll just leave that as it is for right now. So those are your products, minus the delta H formation for IF7 is going to be minus 941, so minus 941. And then after that, all you really got to do is just do a simple math here, so minus 89 here. So add up your 840 and 941. So, or actually subtract this, because when you go ahead and do this, this minus goes inside, it becomes plus. So it's going to be 941 minus 840. So it's going to be 101. So it's going to be 101 plus 2 times the delta H formation for the IF. And then just solve for the delta H formation for the IF. So you can subtract 101 on both sides. Okay, so when you do that, this is going to be minus 190 here, and that's going to be equal to 2 times the delta H formation for the IF, and you can subtract, you can divide both sides by 2, and when you divide both sides by 2, you will get the delta H formation for the IF to be 95 kilojoules, negative 95 rather, per mole. Okay, so this is how you're going to be calculating the delta H of the formation if you are given the delta H of the reaction. All right, so hopefully this video was helpful. If you have any questions, please feel free to leave any message in the comment section.